All right, we're about to tackle one of the most fundamental and honestly one of the most mind-bending rules of reality itself, quantum superposition. This is the idea that the world, way down at the smallest scales, operates in a way that just seems to defy all common sense.
Okay, it all kicks off with this simple but totally reality-shattering idea. See, in the quantum world,
Get this. A single particle, like an electron, can be in multiple states, or even multiple places, all at the very same time.
and no, this is not science fiction, this is a core principle of physics. It's called superposition. And what you'll find is that so many of the bizarre mysteries of the quantum world, they all trace right back to this one single idea.
So, what does that even mean for something to be in multiple states at once? I'm gonna bet it's probably not what you're thinking.
Okay, here's the really crucial point. Superposition doesn't mean a particle is, blinking back and forth between states, or that it's literally torn into pieces. Not at all. It means the particle is in one single, unified state, but that state is a combination of all its possibilities. It's only when we look, when we measure it, that it's forced to pick one and snap into a single outcome.
And this really gets to the heart of the common mistake, right? Our brains want to picture a particle literally in two places. But the quantum reality is, well, it's a lot more subtle than that. The particle is in one state, but that one state holds the potential for every single possible outcome.
So to get a better handle on this, physicists had to stop thinking about particles as tiny little billiard balls. Instead, they started thinking of them more like something fluid. And this leads to this really powerful idea of a wave of possibility.
See, every quantum system, whether it's one electron or a whole atom, is described by this mathematical thing called the wave function. And this is the key to understanding all that potential we were just talking about. You can almost think of the wave function like a recipe for reality. It's got different ingredients or components, and each one represents a possible outcome. The amount of each ingredient, the height of the wave, tells you how likely you are to get that outcome when you finally look. So before you measure, there's no single definite answer. There's just this beautiful, rich cloud of possibilities.
Okay, I know this all sounds super abstract and theoretical, but here's the thing. We can actually see the effects of superposition in action, and it's in what is probably the most famous, most mind-blowing experiment in all of physics.
So here's what happens. You fire electrons, one by one, at a wall with two little slits in it. And something just incredible happens. Each individual electron acts as if it went through both slits at the same time. These two possible paths, which exist together in superposition, actually interfere with each other, kind of like ripples in a pond. And the result? You get this distinct wave-like interference pattern on the detector screen, a pattern that a single particle should never be able to make.
So naturally, you're asking the obvious question, right? Which slit did it actually go through? Come on, was it the left one or the right one? We have to know. And this is where it gets just completely bonkers. The moment we try to find out, the second we put a little detector at the slits to ask which path the electron takes, the whole game changes. The very act of looking forces the electron out of its superposition. It's forced to pick one path, and just like that, poof, the interference pattern completely disappears.
Okay, so if this is how reality works at the bottom, then why don't we see it everywhere, right? Why isn't my coffee mug in a superposition of being on my desk and on the floor? Why does our big, everyday world seem so solid and definite?
Well, the answer has a name. It's a process called decoherence. You see, a quantum system can only hold on to that fragile, spooky superposition if it's perfectly isolated. The instant it interacts with its environment, even a little bit, that superposition shatters, and it's forced to behave like a normal, classical object.
And for something big like a cat or a coffee mug, that interaction is constant. It's overwhelming. I mean, every single air molecule bumping into it, every tiny vibration, every little fluctuation in temperature, all of that is a form of measurement. The environment is constantly asking the object, "Where are you? Where are you?" And it collapses the superposition so fast we could never, ever hope to see it.
But here's the thing. Just because we don't see it in our day-to-day lives doesn't mean it's not real. Superposition is happening all the time, under the surface. In fact, it's the foundation for some incredible technologies we rely on and are building right now.
For instance, the way electrons exist in atoms isn't like tiny planets orbiting a sun. They're in a superposition of possible locations called an orbital. It's why superconductors can carry electricity with zero resistance. And, of course, the big one, superposition is the engine that's going to power quantum computers.
Think about it like this. A regular computer bit is simple. It's either a 0 or a 1. That's it. But a quantum bit, a qubit, can be a 0, a 1, or a superposition of both at the very same time. And it's that ability, the power to hold and process all those possibilities at once, that gives quantum computers their mind-boggling potential.
So, we've got the math down. The equations for superposition work perfectly. They make some of the most accurate predictions in all of science. But what does it all mean? What is it telling us about the true nature of reality? Well, that's where things get really controversial.
There are a few big competing ideas. You've got the classic Copenhagen interpretation, which says reality is fuzzy until we look, and then it collapses into one state. Then there's the wild many worlds idea that says every possibility actually happens, but in its own separate parallel universe. There are others too that talk about hidden pilot waves. The crazy thing is, nobody knows who's right. They are all just different ways of trying to make sense of the same bizarre experimental facts.
So when you boil it all down, the most important takeaway is this. Superposition isn't some strange, rare exception. It is the rule. It's the default state of reality at the deepest level. Our solid, predictable, classical world, that's the exception. It's just what's left over after that deep quantum weirdness gets washed away by constant interaction with everything around it.
And that leaves us with one last, huge, fascinating question to chew on. If superposition is the fundamental rule, and not the exception, what other parts of our reality are being secretly governed by this hidden quantum dance? I mean, from the Big Bang all the way to the nature of consciousness itself, what else is built on this foundation of pure possibility?